Well, Mark, thank you for coming on the Tailwind podcast.
Thanks for having me.
Of course, yeah, I'm a huge fan of your book, which is called Focus and tells the story of the great Dutch tech company ASML, which we're going to talk about today. Wondering if we could just start off, if you could tell us a little bit about your background and what is it about ASML that prompted you to write this book?
Okay, well, my day job is a technology reporter for the Dutch newspaper NRC from Amsterdam. And I used to write a lot about the US tech companies because, well, they're big in Europe as well. You know the drill, the Apples and Microsoft and Google. But during COVID, I wasn't able to travel like the rest of the world. So I started looking into my own country, seeing what do we have as a technology company themselves. And I had been following ASML for quite a while, but mainly as a financial reporter. And I got to know the company as, this sort of obscure, high-tech, deep tech company, you could call it, from the south of the Netherlands, from a town called Eindhoven. They really were a spin-off from Philips, and they got quite big, but they made chip machines, and nobody cared about semiconductors in the Netherlands because we don't have the fabs. The fabs are in Asia or in the US. But I got interested in this technology that ASML was producing because they really were on the verge of creating accuracy in their machines and creating chips with these machines that are capable of writing the finest lines. And they were explaining to me in a way that I found fascinating. And during COVID, I reached out to the company and said, okay, what are your thoughts about me spending 1 year behind the scenes at ASML? How you're coping with all the obstructions in your supply chain? And I'll write one story. I won't do any news during that time. And I will write one long read and publish it in the end of the year. And they agreed to it. So that was in 21. And there was just when shit hit the fan. So when the chip shortage hit, and also when all the geopolitical turmoil broke out and hit ASML. And there was already discussion about their EV technology. We'll dive into that later. But 21 was also the year that also the other advanced lithography machines of ASML were being controlled, first by the US government and also by the Dutch government. And I got a chance to witness that process at ASML and write it up in a story. And then at the same time, ASML was on the verge of changing leadership. So their old leadership was leaving. They were ready for the pension, and there was a new leadership coming in. And when the story was published, the long read, an Amsterdam publisher reached out to me and said, hey, isn't there a book in it? So I went back to ASML, gave them some time to think, and I suggested them to actually prolong the period of me spending time behind the scenes. So give me the chance to write the book. Because during the first year, I had found out some of these hidden gems, these stories of the company that weren't told yet. And people were trusting me with details I hadn't read anywhere before. And suddenly all the things started coming together. It was a change in leadership. The company was also 40 years old, exactly. And there was just geopolitical tension that was growing worse and worse. And of course, there was also the new technology of AI, which isn't possible without the machines of ASML. And all these lines came together in this one book called Focus. And well, the response has been tremendous since then.
You definitely picked quite a time to write about this company, which, as we'll get into, has been around since the 80s. Just to set the stage, ASML, they're the best in the world at what they do. And can you just talk about quickly what it is, what's their main product? Where are they in the tech stack of AI?
Well, you look at it from the wrong way, Andrew. So you start with AI, but you should start at the beginning, at the chip level, at the compute, which is produced by companies like TSMC, and they manufacture, mass-produce these chip designs, for example, made by NVIDIA or Apple or Qualcomm. And they need machines to write all these fine patterns. So ASML actually builds, I call them giant copiers, very complex copiers, and they're capable of printing these fine structures on a silicon wafer in such a way that it's practically fault-free, so it's error-free, and it's also very fast. And it's also on a level that I usually ask people when I do a presentation, ask people in the audience to look at their fingernails. So I'm asking all the people in your audience to look at their fingernails and just count to three. 1, 2, 3. Pretty fast, actually. And in that time, in the short window of time, you've seen your fingernail grow by 3 nanometers. And that's the kind of accuracy that is in these machines ASML makes. So these giant copiers, they are literally very large when it comes to size, but also have a huge price tag. So the most advanced machines, called high-NA machines, they cost about $400 million. And these machines, well, they take up to 7 Boeing planes to transport them from the Netherlands to Asia or to the US. And it takes about 10 years to design them and to actually mass produce them or semi-mass produce them, because, well, there's not a lot of lithography machines out there. If you look at ASML, it's the market leader. So they have about 90% market share in the normal mainstream lithography machines, because that's the technology they make. And they have 100% market share in the most advanced lithography technology, which is called EUV, extreme ultraviolet. And that's what would be the US expression. That's the cream of the crop.
Yeah.
When it comes to lithography. And ASML was the only company that was capable of creating the light that is necessary for these lithography machines. Because light is actually like a fine liner, which you write to draw lines on a piece of paper. And EUV is like the fine liner, and you could call the other light sources, for example, deep ultraviolet. They're more like markers, big markers. And when you have a fine liner, you can cram more transistors, more compute on the same surface. And this has been going on since the beginning of the semiconductor industry. And it's called Moore's Law. Your audience will definitely know what it is. It's like the doubling of the amount of transistors every, 18 months to 2 years. And this has been going on for a couple of decades. So that's the reason why we have chips they have now over 200 million transistors. And if you also include the third dimension, so the extra layers that are being built on the newest generation of AI chips, you get these chips that have over 1 trillion transistors. That's the next generation. And the only way you can get to that level of accuracy is by using the EUV machines ASML makes.
First of all, you're right. I shouldn't have couched what they do just in terms of AI, because the machines that they make are used to make chips for many other applications than just AI. So that's basically the game in their industry, right? Is just trying to get to shorter and shorter wavelengths. And they've been able to do that better than their competition for what seems like decades now, right?
Yeah, well, if you look just at the wavelength, so the smallest wavelength is EUV, which is about 13 nanometers. And it's 10 times smaller or thinner than the other wavelength, which is DUV. It's 193 nanometers. And that's the technology that's also in machines made by Canon, for example, or by Nikon. But ASML has grown a lot of market share by creating more efficient systems. And they used a different approach than their Japanese competitors, because the company was really focused on the single goal of having the machines available right at the time the customers needed it. So often they would not install these perfect machines, but semi-perfect machines, perfect enough, as they say, and just tweak them together with the customers. So that way, it was like a win-win, because by tweaking them together with the customers, you create a great relationship with the customer, and you also are the first in the fab. So other companies, for example, the Japanese companies, they really insisted on building a perfect technology, just like the digital cameras they make. You only have to put in the plug and the machine works. Well, this was definitely not the way that ASML's approach was. ASML was very much a cowboy attitude. They wanted to be the first in the fab, and this kind of aggressive mode really paid off in the end.
Right. And that was that strategy of basically shipping their products before they were fully 100% ready and optimized. I would say is very sort of Silicon Valley-esque of them. But there are a lot of ways in which they differ from traditional Silicon Valley companies. And we will get to that. Just to back up. So what's the origin story of ASML?
Well, if you look back, the ASML has well, you just have to look at the part numbers because every part number is still the same phrasing or the same logic and order of the numbers of Philips, which is the electronics company from the Netherlands. And Philips was well known for their TVs, hi-fi sets, razors, and of course, they even made computers and chips. And they also tried to make their own chip machines, like lithography machines. And they sort of created the technology for that, but they weren't capable of bringing it to market because as a chip manufacturer yourself, it's very hard to create the tool set and also sell it to your competitors. So there was not an economically viable situation for Philips. So they decided to spin off the company that eventually would be ASML. But this was kind of coincidental because Philips tried to sell the technology to US companies at first. And well, the deal went south. And they also were thinking about just flushing the technology at all because it was costing too much money. Because it's a complex technology, and to do this well, you need a lot of funding. And in the end, the Dutch government kind of saved the technology because they saw the possibilities of lithography. And there was a Dutch pioneer, Arthur del Prado, from the company ASM. You might also know that. And he saw the potential of lithography. So he was like the co-founder together with Philips in the first couple of years of ASML. And these first couple of years, they were horrible. So they didn't have any suppliers. They didn't have any customers. They didn't have a strategy. They only had like this bold attitude. Okay, we're going to just give it a shot. And of course, they had nothing to lose. In the first years, there was like a dip in the semiconductor, in the chip industry. The semiconductor industry is cyclical. So you see these ups and downs. And there was actually a down just when ASML started. So there was a lot of competition that had a rough time. But ASML wasn't hit at all because they didn't have any customers, so there was nothing to lose. And that kind of propelled them at the right time and helped them through the first years. And they also had a lot of funding helping them out with the research, especially from Brussels, from the EU, but also from The Hague, which is where the Dutch government resides. And of course, there were a lot of great engineers. So it really was a technology that Philips discovered was more efficient than a lot of the Japanese and also the US competitors. But they had to create a viable machine which needed, for example, electrical motors instead of hydraulic motors, oil. So the first generation wasn't perfect and they sold 0 of them. And the second generation got a bit of traction. And they were lucky because one of their first customers, TSMC, they had a fire and they sold a couple of machines to Taiwan, to TSMC, back in 87, I think. And because of the fire, TSMC had to replace them and the insurance companies had to pay for like the second order. And the second order was enough for ASML to survive the first couple of years. And of course, this relationship with TSMC, which is like almost 40 years old now, is still going very strong. And it's now the foundation of the fact that there's a foundry now on a small island close to mainland China, which produces practically every AI chip in the world now. And it all goes back to 85, 86, 87, the years when Morris Chang was looking out also for funding and technology for his new idea of building a pure foundry business. And he tried reaching out to Japanese lithography makers and didn't like the idea. They didn't want to help a competitor so close to them. He also reached out to Texas Instruments, his former employer, and also to Intel. And they said, no, we don't see this market growing of pure foundry in Taiwan. So he chose his second best option, which was Philips, also a semiconductor manufacturer. And Philips invested like 28% in TSMC at first. And by this relationship with Philips, they also created an option for ASML, Philips' spin-off or daughter, to ship their first machines to Taiwan. And so 4 decades ago, it started with an accidental move. And now you see these things happening that are quite awesome. TSMC is like the biggest supplier of chips everybody is depending on.
Right. I mean, that relationship between ASML and TSMC is one of the more important sort of business relationships in the world at the moment. And it also speaks to the geopolitical tightrope that ASML has to walk. Do you think ASML being a Dutch company, do you think them being in the Netherlands helps them walk that tightrope more effectively?
I think they consider themselves, because they're a market leader, as the Switzerland of this technology. So they're like a neutral player. They can't help other customers earlier or give them more advantage than other customers, because if they would have such a relationship with the customers, they will shoot themselves in the foot. So they have to be like this neutral player, which is very easy because the Netherlands don't have any chip fabs on their own soil. So it's a neutral player. It provides other players and other companies with this technology. Of course, there's NXP, but most of NXP's production is in Asia. So that makes the Netherlands kind of a neutral party in this. I totally agree.
So let's talk about ASML's supply chain and their supply chain strategy. So, how many parts go into the most up to date lithography machine?
Well, actually, excellent question. But actually, I think even ASML doesn't have the answer to that, because these are hundreds of thousands of parts. And I think one of their suppliers, actually, the German company Trumpf, which makes the laser of the EUV machines, they counted over 450,000 parts just in their laser. And of course, you could regard it as a different part of the machine, because if you look at a semiconductor, well, chip fab, the laser is not on the same floor as the lithography machine. But the lithography machine itself, it's huge. It's like 40 meters wide. It's the largest one, and it's a small building, so to speak. So there's a lot of a lot of parts going into them.
And to what extent are they vertically integrated?
They're not, actually. If you look back at the history of ASML, they started with nothing. So they had to reach out for a lot of other suppliers, especially the optics system, the lenses of the machine. Because like your copier, like your office copier, it also has lenses and moving parts. But the lenses are the main part that ASML really couldn't build itself, and it couldn't also outsource it to Dutch companies, because a lot of the megatronics is made by Dutch companies from the south of the Netherlands, Brabant. But the optics, they come from Germany, from the company you might know from your prescription glasses called Zeiss. And they also made photography lenses, and they also make these huge lenses. So we're talking about 3 feet in size, or costing millions of dollars a piece. And these are special lenses, optics system, combination of lenses built by a German company.
So here's ASML. They build these machines that have hundreds of thousands of parts, and they have to source probably 90% of these parts from suppliers. So where are most of their suppliers located?
Well, it's mainly like a European ecosystem. So ASML is itself, its headquarters, it's close to Eindhoven. It's a little town called Veldhoven. And their campus is very close to a lot of their suppliers. And these guys have the same culture. They also have usually a background at Philips, because Philips used to be this huge electronic firm, but it was once successful, but it wasn't capable of competing with, for example, Chinese companies or Japanese companies. So a lot of it was just sold. And there's this whole generation of former Philips employees, engineers that still know each other, but also built their own companies. And these are part of the supplier network of ASML. And so these are mainly the same culture. The big cultural difference was between Zeiss, so the optic systems supplier, which is a German company. And German companies are, well, they have a much more hierarchy in their culture. And there's also a different pace. So if you look at, for example, the production process of these lenses, they take years to accomplish, because you need to polish these lenses. And it's kind of a different process than building megatronics. So these companies weren't aligned when it came to culture, but also just the amount of time they needed to finish their products. And it took quite a lot of time to have them figure out a way to cooperate. They're cooperating so well that they even share their own IP from day one. But it took a lot of swearing, a lot of fights, a lot of commercial negotiations. But in the end, the result is that they like acting like one company. They have two names, but they're both, billion-dollar companies now.
The supply chain was, I thought, one of the more fascinating parts of the book because these machines, yes, they're produced by ASML, but they're really produced from a region. And it's a region that is filled with these former Philips employees who left. I think kind of what you described is they could sense Philips was not going as well, and they left to start their own companies.
And Andrew, what was like a weak spot because they weren't vertically integrated and they couldn't build everything themselves. But that weak spot turned out to be a very big advantage because they got to share knowledge and do this open innovational system where it is easier to spread knowledge and gather more brilliant minds together and solve these complex problems. And at the same time, when there's this downturn in the semiconductor industry, the competitors usually reacted by cutting in their R&D fund. So they spent less on R&D because they made less profit. But ASML, because it outsourced so much, it didn't have to cut as much in their own expenses. So they kept spending a lot of money in R&D during these downturns. And when there was this uptick in the market, they really had a big advantage compared to the competitors. So that helped them create a bigger market share. And the reason for that is that ASML had this massive amount of outsourced material in the machines. It made them leaner, more agile than their Japanese competitors.
Yeah, it's not easy to be. You would think being a supplier to ASML is a great position to be in. You're supplying to this booming company, but it's actually quite difficult, right? Because they ask a lot of their suppliers.
Yeah, and the funny thing, if you look at the chip fab, there's a lot of single sourcing going on. So ASML is like the market leader in lithography, but there's a lot of single sourcing also on the level of ASML's machines. So, for example, Zeiss is the only source for the optic system. There's no backup plan for that. And you see all these modules in the ASML machines, they don't have a backup supplier. So it creates a huge band of trust and sometimes even shared IP and a very long-lasting relationship. And that's the kind of relationship the ecosystem thrives on. And the only way to get there. So you have this great bond between all the suppliers, but it's very hard because the market can have these huge downturns and upturns. So sometimes you have to double your production in a couple of months' time, and sometimes you have to cut your production and take your losses. And especially during the early days, ASML was not good in predicting the health of the semiconductor industry. And that made it very tough for the suppliers because they couldn't predict as well what parts they had to buy, how many employees they needed. And of course, it helped ASML being lean and agile and responsive to the market, but it had to be digested by the supply system as well. And sometimes companies went south. They went bankrupt because they couldn't keep it up. And ASML, it grew more responsible. It also asked from suppliers, well, to not be too dependent on ASML. So try to keep your revenue divided over several other customers. And that was easy during the time when ASML was still relatively small. But now, of course, the company is growing rapidly. It has now 30 billion euros in revenue, and it expects to double that in the next decade. So the supply chain has to grow accordingly. And it's not easy. And ASML is not the easiest customer. So if they want and if they need their parts in time, they'll do anything to help you, to force you, because they want to have the machines with the customers right on time. Because otherwise, TSMC will have a problem. Samsung will have a problem. Intel will have a problem. And the customer is always number one. It sounds a bit corny, but it really is ingrained at the company and also at the suppliers.
Just to respond to what you said there, I think you say in the book that ASML mandates that a maximum of 40% of a supplier's revenue can come from ASML.
Yeah, 40, and sometimes it's 50, but the goal is 40 because otherwise they're too dependent on the company.
Right. So overall, it's not a totally easy gig to be a supplier to ASML. So to switch gears a little bit, you brought up the sort of cultural clash between Zeiss and ASML. What is the culture like at ASML?
I don't know if you know any Dutch people, but they're usually very blunt and can be a bit overwhelming sometimes. And they're usually not very subtle. So that's the Dutch style. But you have to multiply that with the engineering style, which is also very direct because you can't beat around the bush if you're tackling all these hardware issues that are physics or chemical issues that you encounter when you're building lithography machines. So that's like Dutch and engineering culture and all these complex problems and all these engineers competing because they all want to be like the smartest guy or girl in the room. And you have a very direct culture that is mainly about challenging each other, constant challenging, not only in a horizontal way. So it's also the leadership that expects you to challenge your bosses. And I think that's typically Dutch because we're not used to having a lot of respect for authorities. And that attitude is ingrained in the ASML culture. So it's very direct. It can be obtrusive. And I spoke to a lot of the US employees at ASML because about 8 or 9,000 people in the US work for ASML as well. And they got used to it, but they would never treat their family members like that. That's what they tell me. And the funny thing is, you save a lot of time. So you could compare it with the same principles as building a chip or a computer. So you want to cut out the latency. So restricting latency is, well, just don't beat around the bush. Don't say, well, we might save this next week. Just say what your problem is, and we'll all try to help it in like a parallel fashion. Actually, they cooperate a bit like a GPU themselves, a lot of parallel processes and a lot of direct interrupts, which means somebody is just trying to hide a problem. Well, that doesn't work at ASML. And other cultures have to adjust to that. And I think there are like 144 different nationalities working at ASML, and a lot of their international employees are having a rough time adopting to that culture. And they try to make it easier to land on planet ASML, but it's even for a Dutch person, it's quite a confrontational culture. But they're very open to criticism, and that helped me writing the book. They were willing to admit their failures because it's very much ingrained in the company that you have to be challenged all the time because everybody is trying to find errors you make, failures you make, because that's the way you learn. And you have to find as many failures in the system at the time when the machine is still within the company. So you prevent failures when the machine is running 24/7 in a fab somewhere. And the funny thing is, they were open to critical questions as well. And the leadership wasn't too fond of some of the topics I addressed in the book, especially when it came to culture or things you just screwed up. But they were willing to admit it. And I really liked the fact that I could be an objective mirror to the company. And I think that makes ASML stand apart from other companies that have a listing and they have a tendency, well, to create the best or the most brilliant story. Well, and there's a lot of modesty there because they know that it's very easy to screw up a business like this. So that helped me as a journalist also finding the stories they didn't want out. And they also allowed me to just find other sources for the same story because, of course, it's a story about the company, but it's also a story about their role in the world and the way they are perceived by governments, by their employees, by the customers, and by their suppliers.
One of the beacons and maybe the stewards of that communication style you mentioned is the man who, up until very recently, was the CTO and president, named Martin Van Brink. What role did he play or has he played at ASML, and what does he like to work with?
So I spoke to Martin for this book, I think about 5 times. And these were quite hectic interviews, but because he's a very direct person, he's like the nucleus of ASML culture. So all this this direct approach, but also the transparent approach and the challenging part is very much like his mindset. And also about being modest when it comes to your customers. The customer is always right, because otherwise you're going to be complacent, and that's the fastest way to get your company in trouble. And so this is very much Martin's mindset. He's not easy to work with. You have to really gain his trust, and it took me a while. But once you gain his trust, he's willing to share a lot of details, a lot of stories, and also challenge you to get more of ASML or dive into technology. He's a great teacher, but he's also a great teaser. So he really likes to annoy people, just rub them off, just to see how they respond. It's like he's pressing all of your buttons at the same time, just like some of the people who work with him compared him like a cat playing with a mouse. So he really enjoys that game. And he thinks that's the best way to challenge people, but he also expects people to challenge him. So there was this mutual respect, but it took a while. But in the end, he was quite emotional. It was during the last interview when he was, I think, in his last days, just before he went on his pensionate. Actually, he's still an advisor for ASML. He's still a very important person when it comes to cultural and also the technical part. But he was very emotional during that last interview and opened up in a way I never expected. So it was nice to be a witness of that. But if you look at Martin's role, he really started out as, well, the first employee. Actually, was employee number 0, because he started at the company when it was still called Philips 40 years ago. And his role in the company grew. First was one of the early staff. It was very enthusiastic about this new technology. And actually, the first couple of employees who started at Philips and were spun off, they weren't too happy about it, because Philips was a great employer and ASML was very insecure during this first couple of years. Martin was eager. He wanted to dive into the technology. And because he's such a powerful person, it was great to have him as a protagonist in the book, because he's brutally honest also with his customers. Is able to advise the customers to not buy ASML machines because it's not the best technology, which, well, it may hurt them on the short term, but Martin was the one who also built the roadmap together with IMEC, the Belgian institute that's like the playground for the whole semiconductor industry. And together they built these roadmaps looking ahead 10 to 15 years. Okay, so this is the technology you're going to need in your new devices, in your new computers, smartphones, AI chips. Well, we're going to provide the technology for that, and we'll keep the industry aligned. So Martin van der Brink was really like this nucleus when it comes to developing the manufacturing technology for tomorrow's chips.
ASML does not have a founder CEO that is sort of typically associated with it, like Jeff Bezos or Mark Zuckerberg or something like that. But Martin seems to be the closest to that, right?
Well, if you look back, Martin had a lot of other CEOs who tried to temper him, which was very hard because he was a very confrontational figure. So he always tried to challenge the CEOs. But I guess he also was capable of training a lot of other people around him. For example, the new CEO, the Frenchman called Christophe Fouquet, he was actually hired by Martin van der Brink back in 2007. So it was Martin who saw the talent of Christophe Fouquet, who was working at a US chip machine manufacturer called KLA that back in the day. So he kind of nurtured his successors as well. And his culture is really ingrained in the company. And of course, I agree it will change over time. But I think the fact that ASML didn't have a founder CEO kind of helped the company, because that way the hierarchy is still low. There's not one person calling the shots, because, well, you've read the book. The problems they have to solve are so hard. Nobody's capable of knowing how this machine works. Even at ASML, people don't know all the parts. A machine still has riddles, even for the most experienced engineers at ASML. And if you have like this one top dog that is supposed to know everything, you kind of limit yourself, and you have to widen up and create a parallel path of knowledge, of experience. And that's the ASML way.
That's fascinating to hear you say that about them not having a founder CEO. And I think that's one of the interesting things about this story is that the way that ASML was built, in my mind, deviates from how the sort of traditional plan of how large tech companies have been built. It was a spin out. There was not a venture capital firm involved. The folks that were involved early on, like the wealthy entrepreneur you mentioned, he was no longer involved after a few years. The first CEO they brought on was gone after 4 years. And Martin, who is the sort of heart and soul, was never CEO.
I totally agree. So, from an American perspective, it's totally atypical. But if you look at it from a European perspective, it makes complete sense because it's also in the book. ASML has like this Rhenish model. So there's a lot of companies involved there that are in it for the long run. So it's not about this aggressive Anglo-Saxon profit optimizing culture. It's about creating relationships for the long term, for the benefit for the next couple of decades, and for the benefit of the network, of the ecosystem. And that mindset is really necessary for solving these complex problems like lithography machines. I don't want to dive too much into technology, but you're really talking about, so the accuracy of the hardware is very hard to predict. So you really have these nanometer small details in the parts in the machines. There's also, it's very easy to have a bit of deviation because of temperature, because of gravity, because of, well, cow farts in the distance. That's also part of the story. There are so many factors that can have an influence on chip manufacturing, and that you really need to have this marriage between hardware and software, software correcting all these little errors in the mechanical parts. So this marriage of chemistry, building hardware, doing software calculations, using AI to find the errors in the chips, and also to make the lenses correct the light source. That's a combination of problems that's impossible to solve for just one person or one company. So you really need a multitude of companies, of brilliant minds working together. And I think ASML's biggest secret is that it always was able to be a one-trick pony. So to build these machines, of course, they have a lot of different machines, but the end product is still a lithography machine. It's still a giant copier. It has the same function in the chip fab. It's like the main tool. And ASML was, sometimes it was distracted a bit, but there was also always Martin saying, okay, let's get back to the core of our business, building best machines for the chip manufacturers. Andrew had some questions for me. Just to finish our discussion, what was your favorite part of the book? What did you think was most interesting? Because you have an investor background.
Well, I think, like I said, the degree to which it deviates from how these Silicon Valley tech companies have been built, because I think as an investor, I'm always trying to figure out what's going to work and what's not going to work. And I live in Silicon Valley, or I'm in the Bay Area, so I'm bombarded with these best practices, and it's all kind of the same way of thinking about how to build companies. And to see this story, and like I said, there's no founder CEO. It was a spin out. All these different people were involved early on, and then pretty much none of them were involved except for Martin for quite a while. And I just think that was fascinating. I love the supply chain part where I think it was, maybe 5 or 10 pages you spent on one of the founders of one of the suppliers, which it was like a family owned business. And you talk about the struggles that they have in working with ASML, but the juice is worth the squeeze because it's still worth it for them. I thought that was fascinating too. And yeah, it was a great book.
It's good to see that people appreciate it as a different story than the Silicon Valley success, but it wouldn't be possible without the success of Silicon Valley. And actually the first headquarters was built in a Silicon Valley fashion. So it really looked like a building you could find in San Jose or in Menlo Park, because they wanted to have their US customers out there. And back in the day when Silicon Valley was still Silicon Valley.
They did. Yeah. Well, Mark, it was a great book. As I said, I bought it because I just wanted to learn about ASML. So I went into it thinking it was almost like a homework assignment. Like I needed to learn this information. But about 20 pages in, I was like, this is an awesome book. And it was a page turner. And it was super easy to read, which is saying something because it's a very technical subject. And the explanations, I thought the diagrams of how the machines work, the different components of the machine were so helpful. So, yeah, it was
Oh,
great
cool.
and really enjoyed it. Marc Hijink, thanks for coming on the podcast to talk about your book.
Andrew, I had a great time.